Alright everybody, we're going to talk about section 7.3 today. It's going to be about long division and synthetic division. So mainly the reasons why we need to go through this are because we're going to use this in order to graph polynomials at the end of the chapter, and also this is going to help us factor polynomials, which will also help us graph. So this is going to be kind of the basis for what you're going to see in the next couple of sections. Long division, you learned a long time ago when you first started to divide 5 divided by 3 and 20 divided by 7, and you learned how to do it with the little brackets, and you would fill in the numbers and you carry down a number. It's the same concept, except this time we're going to be dealing with variables and with polynomials. So I'm just going to go through a really basic example to start. So make sure you follow through these steps, and if you need to pause as we go through it, make sure you do. The first one, we're going to have x squared plus x minus 17, and I'm dividing that by x minus 4. Okay, so when we start this, whatever comes first is going to be what goes underneath your bracket. Okay, so we'll put in our x squared plus x and then minus 17 here, and then whatever you're dividing by goes on the outside, so x minus 4. Now it's important to remember that you want this to be in standard form, so that means from the highest exponent down to the smallest exponent, and you also want to make sure that everything is there. So if you have an x squared, then you need to make sure you have an x, and then you have the constant, and if you don't, you're going to have to replace those with zeros, and we'll go through examples with that here in a little bit. But what you want to do is basically start with your x value, with what you're dividing by, and then you're going to want to do some multiplication. So x times something is going to get you x squared. Well, x times what gets you x squared? Well, that would be x. So what we're going to do is going to take an x and put it under the x column. Okay. So now I'm just basically going to distribute. So I'm going to take the x times x, which gets me x squared. And then I'm going to take, so that I did x times x, and then I'm going to take x times the negative 4, and that's going to get me minus 4x. And so the goal in these types of problems is to make sure that what you multiply with on the top and what's on the outside of the box here matches up with exponents. Okay, if they're not x squared, then you need to make sure you change what your answer is. And then after you've gotten this all multiplied out, you're just going to do some subtraction. So we would subtract this, which means we change that sign, and this cancels out the x squared. X plus 4x gets us 5x, and then the next step we bring down the negative 17. Okay, so we're done with step 1. Now we're going to do the same thing, but with this equation here. So x times what gets us 5x? Well, x times 5 gets us 5x. So I'm going to put a positive 5 up there above the constant, and then I'm going to multiply like I did just a second ago. So 5 times x is 5x, and then 5 times 4 is, negative 4 is negative 20. And then remember, we said we're going to subtract, so I changed the signs, and my 5x's cancel out. And what's negative 17 plus 20? That gets us positive 3. So now we have a problem, because when we usually divide, we want something to go in evenly, but this doesn't come out with a 0, so this is where we have our remainder. And in order to write a remainder, let me erase some of this up here, what you're going to do is take the answer you got at the bottom over what you divided by. So I'm going to add on to my equation, so plus, because it's a positive 3 over x minus 4. So this right there is your whole answer. So it doesn't go in evenly, and that's okay, but obviously you could still divide. So my final answer here would be x plus 5 plus 3 over x minus 4, and I would be done. Okay. Like I said, this is a process you've learned before, but now we're just adding variables, so it might be a little complicated at first. If you're stuck on any problem or on a step, pause it and just come ask me really quickly. So what I want you to do is I want you to try this one on your own. The only difference in this one from the last example is that now we have an x cubed. So instead of taking x times x to get us x squared, you might have to take x times something else to get you x cubed. So pause the video, try it out, and then check your answer. Okay, so this is how you should have set up your equation, and then I'm just gonna quickly go through the answer. X times x squared is going to get me an x cubed. So I multiply x squared times x is x cubed, and x squared times 2 is positive 2x squared. And then I subtract. So this becomes a minus, and that becomes a minus. And when I subtract, I cancel out my x cubes. Negative x squared minus 2x squared gets us negative 3x squared. And I bring down my 4x. Then I continue. X times negative 3x is going to get me negative 3x squared. So negative 3x times x, negative 3x squared. And then negative 3x times 2 is negative 6x. Then I change my signs because I'm subtracting. My 3x squareds cancel, and 4x plus 6x is 10x. Then I bring down the last one, so negative 10. And then, of course, x times what is going to get us 10x? That's 10. So plus 10. So I would get, 10 times x is 10x. And then 10 times 2 is positive 20. And I subtract by changing my signs. So my 10x's cancel, and I get negative 30 as the remainder. And remember, because we're dealing with remainders, that remainder would go back up at the top as a minus this time 30 over x plus 2. So this right here that I'm scribbling around, that's your final answer. So if you have any questions, make sure you come ask me, but it's all just multiplication, subtraction, making sure you got your signs right. Otherwise, it shouldn't be too difficult. Now, synthetic division, most of you guys are going to like a lot better because you're only going to be dealing with numbers instead of all the variables. So in synthetic division, it's going to be a very similar process to what you did in the synthetic substitution that you did from section 2, where you're going to make your box and write all the coefficients. So let me start off by a basic example. Let's say we've got x cubed, x cubed minus 5x squared minus 2, and I want to divide that by x minus 4. So when I start my synthetic division, I first want to make my box like I did in synthetic substitution. So I've got this box. It looks kind of like the upside down one that you do in the long division. And then I'm going to go ahead and start filling in my coefficients. Now this is where you have to be very careful. You always want to make sure that it's in standard form, so highest exponent down to the smallest. And if you're missing something, you have to put the coefficient as a 0. So we have our x cubed, that's the highest. Well, what's the coefficient? That's a 1. Then my next highest is a squared, and it's in a coefficient of negative 5. Well, what should come next? An x should, but there is no x in the equation, and that doesn't make it wrong, it just means that there isn't one. So if there's no x, I'm going to replace it with a 0. And then the last thing that would come is the constant, so negative 2. So there's my coefficients to start, and you have to have the 0, otherwise it will mess up your problem. And then you're going to use this x minus 4, and instead of just writing x minus 4 over here, what you're going to do is change the sign of this x minus 4 so that it becomes a positive 4. Because remember, we're only dealing with numbers now, no variables. So now I'm going to start the process of my synthetic division, and this is the same thing we did in the substitution. You bring down the first number, so that gets you a 1, and then we start to multiply. 4 times 1 is 4, and then we add. So negative 5 plus 4 gets you negative 1. 4 times negative 1 is negative 4, and then we add. So 0 plus negative 4 is negative 4, and then 4 times negative 4 is negative 16, and when we add those together, we get negative 18. So this is not going to be our final answer because it's just a bunch of numbers, but this is going to tell us what our final answer is. And I think this is going to be the most helpful out of the two for you because this is what we'll use when we factor as well. So now what you need to do is take this equation and write an equation from it, or take the numbers and write an equation from it. So we've just divided, correct? Which means that we have decreased every exponent by 1, because when we're dividing by something, we're taking something away. So if our highest exponent was a 3, our answer now is going to have an exponent of a 2. So what we're going to do is take the numbers that we've gotten down here, and I'm going to just kind of squiggle around them, and we're going to write a new equation with them. And our highest exponent is going to be a squared, so this is going to be the coefficient, 1x squared. Okay, and it's a squared because this was a 3 and we go down 1. Then the next one is going to be a negative 1x because this a negative 1 is our coefficient and we're just going down a degree. The next lowest thing would be our constant, which is just a negative 4. And then the last number is always your remainder. So I'll put a little arrow here. That's your remainder. So then we will have minus 18 over whatever we divided by, x minus 4. So this right here is going to be your final answer. All right. So we've just done our synthetic division, reduced everything down as much as we could, made sure we had that 0 in for the x, and then we rewrote our final equation 1 degree lower than the original. And don't forget that remainder. So please go ahead and press the pause button and try this one on your own using synthetic division, so this method we just learned. Okay, so this should be what you got from your synthetic division just by writing the coefficients in and then changing my x plus 3 to a negative 3. So all I did was write in the 1, 4, negative 1, negative 1. I brought down my first one, and then I started multiplying and adding until I was all the way at the end. Now, this one didn't have anything missing, so there was no need to have any zeros. We had all of our coefficients. And now what our last step is to just write an equation out of our new numbers. So remember, this exponent was a cube, so that it's going to go down a degree. So this means our answer here will be 1x squared. Then plus 1x, then the negative 4 is going to be our constant, and then that is our remainder. So plus, this time, 11 over what we divided by, x plus 3. And if any of these come out as a remainder, which they will in here in a minute, or as a 0, I mean, that means there is no remainder and it went into it evenly, and that's going to be really helpful when we get to factor. So let's just go through our factor theorem. The next two examples are very similar to each other, and we're going to go through them pretty quickly. If it's a factor, that means that it has a remainder of 0 because it goes into something evenly. And so what we want when we have our factoring, when we're factoring polynomials, is to have that remainder of 0 because that means that we don't have to have any ugly fractions. So what we're going to do here is I'm going to give you an equation, and I'm going to tell you what a factor is. I'm going to say, okay, this equation is a factor for sure. And then you're going to use that to factor the rest of the polynomial completely. So if we look at example 3 here, we have this cubic function, x cubed minus 2x squared minus 40x minus 64. And I am going to tell you that x minus 8 is a factor. So what that means is that it should divide into it evenly. Alright, so what we're going to do is use that and go ahead and use some synthetic division just because it's quicker. So I'm going to write my box. I'm going to write my coefficients, 1, negative 2, negative 40, and negative 64. And then I'm going to write my dividend over here, x minus 8, that gets you positive 8. Okay, and I'm going to go ahead and start multiplying. So I bring down my 1, 8 times 1 is 8. Negative 2 plus 8 gets you 6. Well, 8 times 6 is 48. Then if I go ahead and add this, I get negative 40 plus 48, that's positive 8. And 8 times 8 gets you 64. And when you add negative 64 and positive 64, you get a 0. So this is what I mean by you're getting a remainder of 0. That means it goes into it evenly. Well, we're not done here because it says factor completely. That's important. Right here. So what we're going to do, just like the last example, is write our equation. And what I'm going to also do is I'm going to bring down this x minus 8 that we divided by. Okay, so we've got this x minus 8 that we just used, and I'm going to use my remainder of my coefficients here to write my other equation. Now it was an x cubed, so we're going to go down a degree, so this becomes 1x squared, okay, and then plus 6x, and then plus 8. Now notice that there's no remainder here, so I don't have any fractions. And now what we have is a polynomial right here that can be factored. Okay. And if it can't be factored nicely, you could always use quadratic formula, but most of these are going to factor with relatively easy numbers. So I'm going to go ahead and factor this out. Remember our factoring, hopefully. So I split my x's in the front, and then all my factors of 8 that can get me a potential 6. Well, the only one that works is 2 and 4, so I'm going to have a 2 and a 4 here, and then both of these are pluses, so this is going to be a plus and a plus. And then, of course, I just bring down my x minus 8 that I had at the front. And this is my final answer because I've got it factored entirely. So what this did was it took something that was a cubic function that we may not have known how to factor and brought it down to something that you should know how to factor by now, which is a quadratic, where it's something squared, right? So you're going to use the synthetic division, write your new equation, and then factor it down into the 2 extra sets of parentheses and be finished. Okay, so in this example, you're going to do what we just did in the last example, but you are going to go one step further and solve, which means that you're basically going to be factoring it all the way down and then solving for x so that you get 3 or 2 or however many different answers. So we're going to use our synthetic division, like I've got it set up here. Let me finish drawing the box. The only difference is the way they write this one. So here they give you that a 0 is negative 3. So that's like saying that the factor is x plus 3. Okay, it's always the opposite. So when we write this, if you've got an x in it, you're going to change the sign. If it doesn't have an x with it, you're going to keep it the way it is. So that would be negative 3 there. Now we can go ahead and start our synthetic division. So bring down the 1. Negative 3 times 1 is negative 3. Negative 2 plus negative 3 gets us negative 5. Negative 3 times negative 5 is positive 15, and when we take negative 21 plus 15, we get negative 6, and then negative 3 and negative 6, those multiply to get 18. So here we get a remainder of 0, which is good, because that means it goes into it evenly. So now we're going to go ahead and do our factoring like we did in example 3. So I'm going to have x plus 3. That's what I started with. Okay, that's where I got that negative 3 from. And then remember, we go down a degree, so 1x squared minus 5x minus 6. And then, of course, we can factor the x squared part. So I leave my x plus 3 how it is. And then I have x and x. And what are my factors of 6 that can get me a 5? Well, we've got 1 and 6, and we've got 2 and 3. The key is that we want 1 to be positive and 1 to be negative. So in this case, it's going to have to be the 1 and the 6. So 1 and 6. And we want the 5 to be a negative, which means the 6 has to be. So we have x plus 1 and x minus 6. And if you're not sure if you factored it right, FOIL it out real quick on the side. Do some mental math. Double check your work before you finish. And then this is factored, okay, but it says to solve it. So to solve each of these, we're just going to set each of these equal to 0. So we already know that x has to be equal to negative 3. That's what from this one. Well, now we're going to take this one and set it equal to 0, and that gets us x is equal to negative 1. So there's an answer. And then we're going to set this one equal to 0. X minus 6 equals 0, and add 6 over, and so we get x equals 6. So there's our 3 zeros for this problem. And like I said, this is going to be very, very useful when we have to graph polynomials, because you're going to want to know where those zeros are. Remember, a 0 just means where does it hit the x-axis. And this is just the start of getting ready to hit that next section. If you have any questions, feel free to ask. I've got some extra examples for you if you need it. Otherwise, start working on those practice problems. Thanks for listening.